Welcome to SolidCAM Professor on our series of Getting Started. I'm Sydney, your SolidCAM Professor, and in this session we'll be showing you the machining of this part using 3D milling. We'll start off by doing a rough cut on this part itself, and then we'll be doing a rest machining rough cut to clear out the areas where the first tool could not enter. We'll continue by doing a constant Z cut on the steep walls and a constant step over on the shallow areas such as these radiuses and this floor inside over here, and we'll finish off the outside by doing a linear cut on that floor. If we open up our first operation as shown here, you'll see that we'll be using our target, and in the working area, our working area will be around the border of the part itself, working an offset of 10 millimeters out from the center of that part. I'll be using a 20 millimeter rough end mill to use on the rough cut. If I go to my technology area, we'll be doing a rough cut using a contour option in the rough cut itself. If there are any flats, which there are on this part, I'll be using clean those flats after I finish my rough cuts itself, and I'll be leaving a surface offset of 1 millimeter. Let's just take a quick look at our simulation itself using the Solid Verify simulation, and you'll note that the tool is working on every single one of those areas, doing a rough cut, stepping down the exact amount that it should be stepping down, cleaning the outside and the inside as well until it finishes the part, doing as much as it can do with this type of tool. Now in my next operation I'll be doing a rough cut again, but this time taking smaller steps to make it more feasible for a finished cut, but only working those areas that need to be cut. So if I open up this operation that we've done over here, and if I go into my working area, I'll be using the same working area I did last time, but I'll also add in one more note: cut only the rest material. This will allow the tool to work only in those areas that need to be cut, with this material to be taken off. My technology area, again I'll be using my rough cut and stepping down every 2 millimeters. Let's take a look at our simulation again using the Solid Verify simulation, and you'll note that the tool itself will only work in those areas with this material to be taken off. It will not work on the outside of this area or in this blank area itself, just on the floor over there, on these walls, and on that floor over there. Now it's more feasible to start doing the finish cut. Now in our next 3 operations we'll be doing our finish cut. In our first operation for our finish cut, we'll be doing what we call a constant Z, working though only on the steep walls as shown in this area over here. So what we've done over here is we've gone into our working area and chosen the option of working on selected faces. If I were to show you those faces, you can see we've actually taken every single one of these faces, including these flatter areas over there. However, we've also added a limit. The limit is to work only in the areas where the wall is steeper than 30 degrees, anywhere between 30 and 90 degrees, because we know that constant Z works best on steeper areas, so therefore it will not work on these areas over here, and also will not work on those radiuses as well. Now in our check faces, we actually have the floors themselves from the outside, and we're just going to make sure that we stay away from those floors by 0.1 millimeters as an offset to make sure we do not touch those floors itself. Now in our technology area we'll be using the constant Z, going down with a scallop of 0.03 as a step down. And if we take a look at our simulation, you'll see that the tool will work only on the wall itself, as you can see with this toolpath over here, and will not work on this area, and will also not work on this area here as well. If we take a look at our Solid Verify simulation, Again, you'll see the tool is working only on these areas as shown over here, and will also only work on this area over here. And as we can also see here with our toolpath generator, you can see that the toolpath is only on these walls over here, inside walls, not on this top area, and not on this flat area inside here as well. Now, in our next operation, we'll be using the same working area, but this time we'll be limiting it between 0 and 32 degrees. In other words, now I do want it to work on these floors and on these radiuses, and the option that I will be using in my technology will be constant step over using pocket auto boundaries. In other words, the boundaries will automatically be taken from our working area, which is limited to these areas over here and to this floor. And if we take a look at our toolpath generator over here, you'll see that it has been created on these floors over here, on this radiuses here on top, and this radius around the part itself. Now, in my next operation, I'd like to do a finish cut of linear just on these outside floors over here. So if I go into my operation, again we're using the target, and in my working areas, I've switched my drive faces and my check faces. Now my drive face is the floor over here, which was before the check faces, and my check faces is just the opposite. This area around here, also staying 0.1 millimeters away. In the technology area, we'll be using linear, and in my data area, we'll have a scallop of 0.01 to give a really nice, smooth finish on the part itself. If we take a look at our Solid Verify for 3D simulation, you'll note that the tool will work on a linear fashion only on that floor itself, staying away from these walls around here, leaving for a nice smooth finish on the part itself. Thank you for joining us on SolidCAM Professor on our series of Getting Started. Take care and have a nice day.